This is one-dimensional distance, so this is on the number line. So the first one, you have -3 and 5. So the distance between -3 and 5, if you look on the number line, we go from -3 to 5. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, which is how we got 8. If you want to do it using absolute value, remember absolute value is the distance that a number is from 0 or a distance between 2 points based on how you use it. So what we're going to do is we're going to do the absolute value of the difference between the two coordinates. The absolute value of the difference. So the difference is subtraction. So my 2 points are -3 and 5. So I'm going to take the absolute value of -3 minus 5, which is -8. And the absolute value of 8, -8, is +8. So that's the other way that we can get the distance. So let's look at -11 and 27. These are a little bit too big to put on the number line to make it easy, so we'll go ahead and find the distance between the two of them using the absolute value. So I'm going to find the difference, the absolute value of the difference. That's what tells us how far apart 2 points are. So I've got -11 and -27. So what that's going to translate into is the negative minus a negative changes to positive. So I have -11 plus 27. So that's going to be +16. And when we find the absolute value of +16, it is in fact 16. So our distance is 16. So that's how we do the one-dimensional distance. So let's look at now using the indicated length. This is our segment addition postulate right here. So we're going to use the segment addition postulate. And what that means is, a postulate, by the way, is something that is just assumed to be true. We can't necessarily prove it. It's not something we can do with proof, but we just know it's true. That's what a postulate is. A theorem is something we can actually prove. So what you're going to actually do is draw your picture. So I have B is between. Now remember, between does not mean middle. Between just means in between. It can be anywhere on the segment. So we're going to have our segment, and B is between A and C. So I'm going to have A, C, and I'm going to put B here. The distance from A to B is 5.3, and the distance from A to C is 6.7. So A to C is 6.7. So find BC. So this is what we're looking for right here. So all we're going to do is take the difference. So I'm going to take the entire segment, which is 6.7, minus this piece, which is 5.3, and that's going to give me the other piece. So 6.7 minus 5.3 is 1.4. So our answer here is 1.4. So let's look at the next one. We're going to do the same thing with AC. We're going to draw our segment. B is between A and C. So I have A and C, and I've got B sitting in here somewhere. AB is 21 from A to B. BC is 4.3. So let's find AC, which is the entire thing. And this one's a little bit easier. We're just going to do the sum. So 21 plus 4.3 is going to equal the distance from A to C, which is 25.3. Now remember, when you're looking at symbols, when you see two letters written back to back with no symbol above them, it means distance or length. Same thing. All right, let's look at number 23. So if I'm looking at number 23, again, I have B is between A and C. So I'm going to draw my segment, A and C, with B hanging out in here in between. A to B is 3x, and B to C is 5x. And then A to C, all the way across, is 8. So what we need to find is x and the length of BC. Well, what I know is the two small parts, 3x and 5x, when I add those together, those are going to equal the entire length of the segment, which happens to be 8. So I'm going to combine those. So 8x, 3x plus 5x is 8x. 8x equals 8. I'm going to divide by 8, and so x equals 1. So there's our first answer. X is 1. Now I'm going to use that 1 to find BC. BC is 5x. So what I'm going to do is I'm going to plug in this 1 for x, because I know x is 1. So BC is 5 times 1, which is 5. Now you can check your answer. That's 8. X is 1. 3 times 1 is 3. 5 times 1 is 5. 3 plus 5 is indeed 8. So we do have the correct answer. Again, 2 letters, no symbol, means distance or length.